Algebra 1 10.9b, dividing a polynomial. Because rational expressions are fractions and fractions are just little division problems, rational expressions indicate division. So when the divisor is not a monomial, we can use long division. Now we did monomial in the last video, and there's a link in this description to go to that one, okay? There's lots of links in the description. So let's say we have x squared plus 5x plus 6, and we're dividing it by x plus 2, a binomial. What we do is we write our long division box, we put our divisor on the outside like we normally would, x plus 2. We write our dividend on the inside, x squared plus 5x plus 6. And if you follow my colors, you're going to see what we're going to do. We divide this first term x squared by the first term x. We ignore this 2 plus 2 for now, okay? We're just going to divide this x squared by x. So how many times can x go into x squared? X times. Now, what we do is we multiply x times x, okay? And that's what makes the x squared. And we put that x squared here. See? Just like regular long division, if this was a 5 and that was a 10, see? 5 goes into 10 2 times. You put the 2 up here, and 2 times that 5 would be the 10 again, see? So we're putting the x squared down here. Now what we do is we multiply this x by the entire x plus 2. And we get x squared plus 2x, because this makes 2x, see? So now we're going to subtract, just like we would in long division. And we're going to take away 2x from 5x. That's going to give us a 3x. And now we drop down the next term, just like we would in long division, see? Now we need to divide this 3x, this red 3x, by the x. Again, we're only using the first term. And x goes into 3x 3 times. Now we multiply this 3 times x plus 2. That gives us 3x plus 6, see? It's our orange. And now we subtract this 3x plus 6 from this 3x plus 6, and we get a 0, and we have a remainder of 0. So our quotient is x plus 3. See that? We can check it by using FOIL. We have x plus 2 times x plus 3. See? We multiply the quotient by the divisor, and that should give us the dividend, just like in regular long division. And when we FOIL it, we get x squared plus 3x plus 2x plus 6. We combine the like terms and we get x squared plus 5x plus 6, which was our original dividend. See? Let's try it again. So we're going to make sure the exponents are in descending order. That's really important. You want to have the largest one, and then you want it to go smaller and smaller and smaller and smaller, okay? So because we have an x squared and an x, the x squared is first, and we know that's x to the first power, isn't it? So that would be the next one, all right? And we're going to divide it by x minus 3. So we've got our division box, and we've got our divisor on the outside, the x minus 3. We have our dividend on the inside here. And the first thing we're going to do is, in the blue, we're going to divide x squared by this first term x. And that gives us an x, because x times x gives us x squared. That's how we know we did it right. So we've got our x squared here. Now we're going to multiply x by x minus 3. See? And that's going to give us x squared minus 3x. See that? Now we're going to subtract this from this. And 2x minus negative 3x, remember, when we subtract integers, we add the opposite. So if we're taking away a negative 3x, that means we're adding a positive 3x. That's how we got the 5x, okay? Now, we drop down this negative 12. We're right here. We drop down this negative 12, and we've got 5x minus 12. Now, we divide this 5x by this first term x. X goes into 5x 5 times. Now we multiply this 5 times the x minus 3, and we get 5x minus 15. And we write it here. Now we subtract 5x, take away 5x is 0, and a negative 12. Remember, we're going to add the opposite, plus a 15 gives us a positive 3. So we have a remainder of 3. So our quotient is x plus 5 and a remainder of 3. X plus 5 with a remainder 3. And we can check by multiplying the quotient to the dividend and adding the remainder. So here was our dividend. All right, see, x minus 3. We're going to multiply it to x plus 5. We're going to multiply these two together. And if we get this dividend, then we know we did it correctly, okay? So we FOIL, and got to remember to add the 3, okay? So we get x squared plus 5x minus 3x minus 15 plus 3, okay? The remainder. We combine the like terms, and 5x minus 3x is 2x. Negative 15 plus 3 is negative 12. Yup, that's our original dividend, so we know it's correct. See? X squared plus 2x minus 12. That can also be written as x plus 5 plus 3, the remainder, over the divisor. We can also write it like that. Isn't that something? See how I got those numbers? Here's the quotient. You put a plus sign, and you put the remainder over the divisor. See? It's the same thing in long division. If you have a remainder in long division, you can write it like that, can't you? If we've got 3 and we're putting it into 10, 3 goes into 10 3 times. 3 times 3 is 9. We subtract and we get 1 left over. And instead of saying remainder 1, we can say 3 and put the remainder over the divisor. See? It's 3 1/3. So that's all we're doing. We're saying x plus 5 plus the remainder over the divisor, just like we would in long division from grade school, okay? All right, we're going to try it one more time with a little bit bigger one. And we have to have our exponents in descending order. So here's x to the third, x to the second, x to the first, all right? And we're going to divide this big polynomial by this binomial, all right? So we have our division box. And we put our dividend inside of it. We've got our divisor on the outside, the 2x plus 3. And the first thing we do is divide that first term, 8x to the third, by the first term, 2x. All right? So if you want to follow me along, I'm coming down this list, and they're color coordinated, okay? So we're going to divide this 8x to the third power by this black 2x. Okay? We're going to ignore the plus 3 for now. And 2x goes into 8x to the third 4 times, and we subtract the exponents, don't we? So this x to the third minus x to the 1 would be x squared, wouldn't it? So that's the quotient rule. So now what we do is we multiply this 4x squared by the 2x plus 3. We multiply the 4x squared by the 2x plus 3, and we get 8x to the third plus 12 squared, x squared, okay? We just distribute it, okay? And we write it right here, and we do our subtraction. And remember, when we subtract, we add the opposite, okay? So if we're subtracting a positive 12, we're going to add a negative 12, and that's going to get us a negative 16 x squared. Now it's this negative 14's turn to come down, all right? We drop it down. We brought down the next term, that negative 14x. And now what we do is we divide this red negative 16x squared by that first term 2x, okay? And 2x can go into a negative 16x squared negative 8x times. If we multiply this negative 8x by this 2x, we'll get negative 16x squared. That's how we know we did it correctly, okay? And now we're going to multiply I'm right here. We're going to multiply the negative 8x by our divisor, 2x plus 3. And we distribute the negative 8x to the 2x, and we get negative 16x, and we distribute the negative 8x to the 3 and get negative 24x. And we write negative 16x squared minus 24x underneath this one. Now we have to subtract, and remember, we got to add the opposite, okay? So if we're subtracting a negative 24, we're going to add a positive 24. That's going to bring us back up to a positive 10, okay? Let me move up so you can see the quotient. So now we've got a positive 10, and it's the time to drop this plus 15 down, okay? Let me back up so you can see. So we subtracted, and we dropped down the plus 15, okay? So now we've got 10x plus 15. Now we say, how many times can this first term 2x fit into the 10x? 5 times. 5 times 2x is 10x. So we're going to multiply 5 times 2x plus 3. We get 10x plus 15, and we write it down here, and we need to subtract it. And 10x plus 15 minus 10x plus 15 is a 0, so we have a 0 remainder. So our quotient turns out to be 4x squared minus 8x plus 5. See? Now, if we want to check it, all we have to do is multiply our quotient by our divisor. And we can use a distributive property to distribute this 2x to each of these terms, and distribute this 3 to each of these terms, and this is what we get. Now we can combine the like terms. We combine the pink ones, the x squareds together, and we get a negative 4x squared. We combine these bluish-green ones together, and we get a negative 14x plus 15 at the end. And you know what? That's our original dividend. That's our original dividend. Look at that. It's the same thing. Let me back up a little bit. See? We've got the same thing, so we know we did it correctly. You know that when you multiply this quotient to this divisor, and you get that dividend, you did it correctly, okay? All right, I know this is really confusing because it's long division with polynomials. But don't worry, if it was really, really bad and hard to follow, I took it one step at a time. Just watch the video again, okay? 10, 12 minutes out of your life, and maybe you'll get it and it'll be okay, all right? Now, my next video is going to be 10.9c. We're going to do this exact same thing, dividing polynomials, but now we're going to do it when we have missing terms. We can actually put a 0 in the place of the missing terms. If you want to see how to divide by a monomial, or we had word problems for reciprocals of a number, or adding and subtracting unlike denominators using a pattern, I've got my algebra word problem playlist link in here, and we did acid mixture, and we even did a money word problem. All those links are going to be in this description, so you can just click on them, okay? All right. So, I hope I was helpful, and I'll see you in the next video, and let's divide some polynomials that have missing terms. All right? Bye.